Hello, everybody. This is Oz. I would like to talk about one-way Anova test today. And let's get started with the data set. We have 4 different types of diets. This could have been like specific diet types like vegan diet, Mediterranean diet, Weight Watchers diet, and keto diet, and so on. Or it could have been any business example where different types of real estate, for example, single family, multifamily, commercial real estate and offices and so on. Or it could have been different marketing strategies or different fraud detection systems. So depending on your major and context, this could have been any kind of data sets where I have different groups and I'm trying to compare and contrast them to see whether there is any significant difference. So first step is to calculate the average for this data. So let me just insert a new column. And here I would like to calculate the mean or average. So we can use the average function in Excel to calculate each diet's average. And these are basically showing the weight losses in 3 months, let's say, in pounds. So I can just do average of these 15 data sets, enter, and then I could just drag it to the right. And you can see the average weight losses here. And what I would like to do is to simplify the view. I can just show as like this. These are the numbers that weight losses. So you can see on average, diet C participants, they lost more weight than other ones. But is it really statistically significant that these differences between the groups? So now what I would like to also calculate is mean of means. So, or in other words, overall mean. So I could calculate the average of these averages, right? Or I could take the average of the whole thing, which is still the same thing, right? Average of average versus the average of the whole. All these observations should be the exact same number. So basically what I would like to do is compare these values to see whether there is a significant difference between groups, because some of the variation comes within the group, within each group, and some of the difference comes from between the groups. So let's focus on, first of all, total sum of squares. So to do that, what I'm going to do is I will just copy this, Control C, and then put it right here, Control V, Control C, Control V. And then I will put here observation numbers, observation 1, 2, all the way till 15. Okay. Now what I can calculate is the total sum of squares. Control B to bold it. Total sum of squares. And as the name implies, basically I will take a difference between my observation, first observation right here, minus the mean of means, and then I will take the square of that so that the positive and negative differences won't cancel each other out. That will be my difference between my each observation with my mean of means. And if I take the square, ways that I will see the distance between them. Again, I take the square because I don't want positive and negative numbers to cancel each other out. But here I will drag this formula down and to the right, and I will use the same mean of means. So I will just click on that and press F4 to lock that cell. All right, now I can just drag it right. And then what I can do is drag it down or double click. Okay. And maybe I'll just delete this one because I have 15 observations. Perfect. So you can see these numbers. Now, next step, what I would like to do is take the total of that. So I will use sum function in Excel to look at all these distances between each observation and overall mean. And you can see this number is 394.3. Okay, perfect. Now, also what I need to calculate is the degree of freedom, which is m times n minus 1. What does that mean? So here I have m different groups. Okay. And then here also I have n different observations. Okay. So what does that mean? It means that if I know the total sum of squares or averages, I should say, of this whole group, and if I know m minus 1 observations, m times n minus 1 observations, which means 15 times 4, I have total of 60 observations. If I know 60 minus 1, 59 observations here, an average of the whole population, I can calculate the last observation. So that means that the last observation is not really free. So there's m times n minus 1 degree of freedom. All right, so let me just do that calculation. So this is m, which is 4, times 15 minus 1, 59 degree of freedom. Perfect. So next thing, this is a total sum of squares. Of some of these differences will come from between again groups, and some of them will come within the groups. So what I would like to do is I would like to again get these titles, Control C, and then Control V. Okay, and here I will calculate the sum of squares, okay, between groups, or I can abbreviate this as SSB, sum of squares between. Maybe I can abbreviate this one to make it easier, SSD, sum of square total. All right, so let's make these calculations. Here you can see that my group average for diet A is right here, minus overall average is right there. And I take square of this again, make sure that positive and negative don't cancel each other out, and see how much deviation do I have between my diet A and the overall average. And here again, I will use the same mean of means. So I will lock that, press F4, but when I drag to the right, I want blue cell to follow me, so I don't need to do anything. But each average here represents the average of 15 observations. That's why I need to multiply this by 15 for each observation, okay? So if I do this calculation, I got here 15.15, and I can drag it, and you can see the values here for each group. Okay, so now what I would like to do is, again, similar to here, I would like to add them all up. Sum of all these differences. So you can see total difference created by between groups is 97 out of total of 394. Okay, now again, I need to calculate my degree of freedom. And here the degree of freedom is, I have 4 groups. So if I know the overall average right here, an average of 3 groups out of 4, I can find the 4th one. So that means that I have degree of freedom m group minus 1. If I know m minus 1, I can find the average value for the mth group. So what I'm going to do is this m minus 1, which is going to be 4 minus 1 degree of freedom. Okay, perfect. So now what I would like to do is we calculate total variation, we calculate the variation between groups. Now I would like to calculate the variation within each group. So again, I would just need these titles, Control C, Control V, Control C, Control V, and I will copy this to Control C, Control V, and okay, what else do I need? Let's see. Okay, I think this should be good. Let me just drag this one up. I think that should work. I have 15 observations, 4 groups. So now what I'm gonna do is calculate the distance between each observation. This is my original data set, minus not the total, mean of means not, I will need to use average of this group. So I want to know how much that deviation comes within diet A. So this is the value. And again, I don't want positive and negative numbers to cancel each other out. I take the square of this. So you can see that this distance is 0.52. And I would like to use this red cell over and over again when I drag it down. So I need to lock the row number. But I don't want to lock the column ladder because I want to be able to, when I drag it right, I want this cell to follow my dragging. So this should work. So you can see 0.52 if I drag it to the right, and I can just drag it down, right? That's perfect. Now I can calculate total sum of squares. Ooh, squares, I have a typo here, sorry about that. Between groups. Sorry, we did only between, within groups. Within. Perfect. So now what I can do is sum all these values. The variation came from within the groups, which is right here. And then now I can also calculate my degree of freedom. In this case, the degree of freedom is m times n minus 1. Okay. So basically, for each diet, I have 15 observations, which is n, minus 1, because if I know the average of diet A, which is 9.18, and if I knew 14 out of 15 observations, I could easily calculate 15. So that's why the degree of freedom for each group is n minus 1, and I have 4 of those, 4 groups, 4 times n minus 1. So let me just do that. 4 times this m, 15 minus 1. Perfect. So you can see the degree of freedom is right here. So now I would like to develop my hypothesis test for this. So my null hypothesis is diet doesn't make a difference. In other words, average mu 1 for the diet A, maybe I should say mu A, is equal to mu B is equal to mu C, average C, and equals to also diet mu average D, weight loss. So that's my null hypothesis, that these averages are the same. Statistically, they don't differ from each other. My alternate hypothesis in this case is it does make a difference. There is a difference statistically between these, okay? So now what I need to calculate, we will assume in hypothesis testing that null hypothesis is correct. Then we can calculate the F statistic. And which is the ratio of two chi-square distributions. And so my numerator, I will call it numerator here, is gonna be coming from sum of squares between groups divided by degree of freedom, which is m minus 1. And then my denominator will be sum of squares within groups divided by its degree of freedom, which is m times n minus 1. Okay, so if I make these calculations right here, my numerator is going to be the deviation I get between groups, which is right here, 97 6.33, divided by its degree of freedom, which is 3. And this number is 32.4. And then I can do the same thing within groups. Here is the sum squared within groups, 296, divided by degree of freedom right here, 56, which will give me 5.3. Okay, perfect. Let me just decrease number of decimals here for degree of freedom. Okay, so what I would like to do is now look at this ratio for this F distribution. So the difference will be, the ratio will be 32 divided by 5. So the intuition-wise here, like I'm looking at how much of that variation comes between groups versus within groups. So the higher this ratio is, shows me more deviation comes between different diets. That means that there's a higher chance of these diets are different from each other. So you can see that the F value is for this data set is 6.12. Okay. And now what I would like to do is compare this value versus my critical F value. And let's calculate critical F value using Excel's inverse function, because I'm not calculating probabilities here. If you want to calculate probability, you need to use FDist. But if I want to convert the probability into a critical threshold, I need to use inverse function, F inverse. And here the probability is, we need to choose always, before we get started actually with our model, our alpha. And maybe I should just type here alpha. In general, we accept, we choose as 0.05. That's in general what we do in science. So what I would like to do is F inverse function. Probability is 0.05. And degree of freedom from between groups is right here, which is 3, comma, degree of freedom within groups, which is right here. Okay. That is going to be, let me just simplify this number for us, 2.77. Okay, so what I see is that my F statistic value from this data is 6.12 versus critical F value is 2.77. So what does this mean? This means that I can reject the null hypothesis. In other words, diet doesn't make a difference. I can reject this because I collected enough evidence to reject it. Again, we don't say that this is not true. We don't say that alternate hypothesis false or true. That's not how we say it. We say we found enough evidence to reject the null hypothesis. Okay, and I can do another approach to this, which is p-value. So I calculate p-value using F distribution. And here my F statistic value was 6.12, and my degree of freedom for between groups was 3, comma, and within groups was 56. So if I calculate this cumulatively, which total area under the F curve will be 0. 0. Let me see, did I make a mistake? I just want to make sure that I don't have any problem here. F distribution. So okay. This cumulative will give me the total area under the curve. Let me just do like this, false. It should give me the value that is not cumulative. So this is the value that is on the tail end of the distribution. Okay, so basically it is 0.012. So what does that mean? That means that if I assume that the null hypothesis is correct, having observations this extreme or more extreme than this is, if I make percent, it's going to be easier, 0.1% chance that I could observe such a big difference between the groups relative to within groups variation, and that randomly happening is 0.1% chance. In other words, this value is less than 0.05. And what I can say is that I've found enough evidence to reject null hypotheses because the p-value is less than 0.05. And this being just a random situation is less than 1%, even like 0.1%. So that's it for this video. Next video, I would like to show the same calculations using built-in Anova function in Excel. Until next video, enjoy business analytics.